Here I want to show how to do supervised classification using QGIS by using the Sentinel-2 image from Copernicus Data Hub or Copernicus Data Space Ecosystem. So once you have downloaded the data, you will load all the Sentinel-2 bands in QGIS. For land use land cover classification, we can utilize the bands such as 2, 3, 4, 8, 11 and 12. In order to do the supervised classification, you will go to SCP plugin, band set. Then you will add all your data here, click OK. Then it should be arranged in the ascending order, that is band 2, 3, 4, 8, 11 and 12. Then you will select the band order, that is Sentinel-2 band 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then your band number, wavelength unit. So you will select micrometer 1E to 6M. And then you will click check create virtual raster band set. Then you will run. It will ask you to save this particular data, and then you will select any folder you want to save. So it successfully created the band or a virtual band or a virtual raster. Then you will go to the folder where you have saved the virtual raster, and then you will load it out here. So uncheck rest of the data and then keep the virtual raster band. Now next thing is you have to create the training sample in order to do supervised classification. So you will click on SCP doc and then you will click on training input. Then you will go to create new training input, click there, and then again you will select a folder, maybe desktop out here, and then name it as training samples or something else, example, and then save. Now you have to train your data. For example, if you are going to do it for built up areas, if you want to classify your land use land cover into maybe built up, forest cover, agriculture and all sorts of things, then next you will click on create a region of interest polygon. You will click there, come here, and then start creating a polygon. You have to press Control in order to create multiple training inputs. So it is recommended to create at least around 50 training inputs to have more accurate land use land cover classification. So for an example, I have created around 5 just to demonstrate. In order to do a demonstration, I am just creating around 5 training points. But when you do it for the real world examples or the real world scenario or the real world analysis, then you have to create at least 50 training points. Then your example MCID, that is microclass name, maybe name it as BUIL, the build-ups, and then class ID as maybe buildings. Then you click save temporary ROI to training input. So it will save. Passion, it will take some time. Now you are done. Now again create the training input for maybe another class, maybe forest area. Now start creating the training sample. Okay, once you're done, now your MC ID will be 2 and then class ID will be again 2, and then name it as maybe VEGTTION vegetation, and then class ID as maybe forest. Click save temporary ROI to training input. So here, so you will create a training point according to the number of classes you want to classify, or if there are certain number of classes existed or is existing in that particular place, then you will create the training sample accordingly, or you will train the different classes accordingly. And then from here again you can change the color, example by clicking out here. If you want to delete the item, you can delete. You can change the MCID, change the color, example like this. Okay, you can select anyone from here. Okay, you can do whatever you wish to. Then now I have created around, let's say, just for the demonstration purpose, I am just creating 2 classes, but in your case you might have created around 7 to 8 different classes of land use land cover. Then you will go to SCP, you will open this SCP, then go to band processing, then you will click on clustering, and then here you have the option, not clustering, it is classification. You will click on classification under band processing, and then select input band set. So I have one band set, example. If you click here, so you can see band set table, it is 1. Then use training as class ID. Then if you want to do maybe random forest, you will click on random forest. Then number of trees 10, that is by default. Then minimum number to split around 2, and then maximum feature if you want to assign, you can assign. So parameter for node splitting, if empty, all features are considered. If squared, the square root of all the feature, if integer number and number of feature, if float number, a fraction of all the fractions. So these are some information given out here for you to decide. Then you will click one versus rest. You will do cross validation. You will balance class weight. You will find best estimator with steps around 5, and then you will calculate the classification confidence raster as well. Okay, and then if you click on help, it will take some time to load this data. Have some passion. Okay, here see, so input and then algorithm, you have maximum likelihood, minimum distance, multi-layer random forest, spectral angle mapping, support SVM, okay, support vector machine, and then pre-trained model. Okay, and then if you go down, you will find the information about each classification techniques, maximum likelihood, maximum then you have multi-layer. Okay, you go down and then you have random forest. So see here, random forest, use the random forest algorithm, tool symbol and frame. So you have to check 1 versus fast. So it means if check perform validation. So one versus rest for node setting. If empty, all features are considered. Okay. If check perform one versus classification. Okay, you want to read more, you click here and then read more about this particular option given out there. Then you will click run and then it will ask you to save your file. So again you will select the folder where you have previously saved rest of the files, such as your virtual raster and then the training sample, and then you will save in desktop somewhere else and then name it as supervised classification and then click save. So it will take some time. Okay, and then this is all to do a supervised classification.